Hello, stream fans. Welcome back. And there's Tuco already. You can see him, Oh, I was gonna say you could see him hanging out in the rack, but apparently he's chosen this as just the right time to jump off. Hey, little Fuzzin. So for anyone who's just now tuning in, this little creature is what this whole project is about. We're working on a kind of epic robot that'll float around this room on wires and point a stabilized camera at this little critter. Maybe he'll be joining me over here now. What do you want? Well, he's gonna have some bolts to take care of his attention soon. Oh! Apparently, if you have the stream window open and I start streaming, it'll autoplay. Good to know, I suppose. So today's stream, I'm planning on focusing on the CAD aspect, so computer-aided design in Fusion 360, or mostly what I'm doing is really not just the CAD in specific, but mechanical design, so trying to figure out how this thing is going to fit together, how it's going to be strong. Let's bring the camera over here, maybe. Hello, everyone. As I struggle to find the right button. So, part of the reason I often flail around with the camera settings is this little pad of buttons that I made has been a little flakier than usual due to the not-so-stable USB power supply that's feeding it currently. But I actually have a replacement device on the way that should probably arrive maybe even today. I just decided I've spent enough time building something and I'm just going to buy something for that after lamenting the build versus buy decision for a bit. And I got just like, basically it's a special purpose keyboard that's just like a long string of 16 keys that I can just stick under the desk, and that should make a pretty good camera switcher. Apparently this gimbal is not actually on there, that's sturdy. Oh yeah, so this is the last render I did of the Winch bot. I like the way it looks. It's fancy. In fact, this is just a render, so I can't spin it around. But it's, you know, you can probably tell it's in 3 pieces in these two different colors. The idea behind this version is that this large blue piece would be most of the kind of mechanical support, and that would get a lot of its strongness just from the bulk of the plastic. And you would end up either screwing or clamping it onto some kind of pole or heavy object, either on the back or on the bottom. And then this piece would come off to provide access to the microcontroller. The other cover on the back would come off to provide access to the mechanical parts. I liked the way this looked, and some of this design seemed compelling. Like, I liked its simplicity, I liked the overall shape. I liked how you could theoretically attach it either on the bottom or on the back. But then I started looking around at the actual areas that I might want to mount this. I didn't really see any place where I'd want to mount it by the floor, since, you know, the floors here are not really something I can screw into. They're concrete, and there are a couple places where I might clamp it to a heavy object, but I think the better mounting options I have are all wall mount. And as far as wall mount, I actually needed an additional degree of freedom. So in a lot of cases, the place where I'd want to put the winch bot isn't necessarily right under the corner of the room. And so if I allowed the cord to exit at a bit of an angle across the wall to the pulley where I'd actually, put that as far in the corner as I could get it, then that would actually give me better, better access to the entire room for the bot. So that's why I started thinking about redoing the mounting strategy, and instead of making the overall enclosure be the kind of sturdy thing that you'd clamp onto, instead I would have effectively a separate mounting plate that you'd bolt onto the wall, and then the mounting plate would just have a single axis that you could kind of spin the winch bot on, so you could tilt it to aim it at the pulley. And that axis would just be an M8 bolt. So then I started thinking about how I could use that M8 bolt as a structural member to actually support all the internal pieces in the winch bot. And so that's what has led to the current design. It doesn't look as nice yet. And in fact, I'm going to back up before the enclosure component happened. Yeah. So these are all the internal pieces for the winch bot so far. I'm going to try to actually keep this on the screen. Oh, percussion drilling. Well, this place is rented, but the tenants actually have a pretty good amount of freedom to do modifications. I could potentially put stuff into the floor, but I think probably mounting on the wall is easier in all of these cases. And then I can start to think about just a single way that this has to be strong, really. So what I'm imagining here is that, let me highlight this bolt. Is this it? Yeah. So this bolt that I'm highlighting, this is a big, long thing. I think this is an M8 by 150 millimeter. So this is what would provide a lot of the structural support for this whole thing. This end would bolt into a captive nut in the mounting plate. So you'd have like a thick piece of, either some kind of sturdy plastic or maybe even metal that would mount on the wall. And then there'd be a nut behind that this would bolt into. So this bolt ends up providing some compression force to hold this whole thing against the wall. But then a lot of what this has to stand up to is its own weight, either pulling this end of the bot down or the force of the robot's weight on the other end pulling it up via the cord here. So actually, this bolt is going to act kind of like a lever, and you can imagine over here there's the lever fulcrum, and then you want kind of enough of a heel over here so that as this part of the winch bot tries to angle up or down, that you end up with something kind of with some wide spacing up against the mounting plate that ends up distributing that force and acting as the kind of the other end of the lever, if that makes sense. So I was thinking about designing this such that all of the structural components end up kind of transmitting their force eventually into this bolt. So you can see here a lot of the most critical pieces, like here's the load cell. The load cell is mounted using these screws, and then there would be a plastic member that would end up attaching these screws to this screw, which would then end up attaching to this. So you can see I'm trying to keep the amount of plastic there that needs to be really strong, kind of relatively small, so that I can, ideally if I design this right, I have the layers that this is 3D printed with actually just kind of lined up so that the strong parts are holding these bolts together around this bolt's outline, for example. So for example, if I printed it with the print bed down, you can imagine all those loops of plastic just going around these bolts, kind of lashing them together around the other bolt. So I think that would make a pretty strong bracket, even though, the actual bulk strength of the material might not be that big. You can also see these bolts kind of out in space. Those hold the two halves of the enclosure together. They also work to do, I think this is going to accomplish most of the work in holding, bracing this entire half of the enclosure such that it can hold the center of this bearing. So anyway, that's kind of how these parts pack together. Just for a quick outline, this is of course the spool that the cord wraps around. The cord follows this path where, it'll be bundled around here, up to about 150 feet of it. Then it goes around this first idler pulley, which is actually angled like this to try to keep the cord aligned so that even if it's kind of, weaving back and forth around this, it will end up centered on this idler so that it can end up going straight into this idler. And I think that might also help this wind a little bit better, but This is honestly one of the parts of the design I'm not really sure about. Like, I don't know whether I need these to be two separate idlers or if I can get away with consolidating these into one piece. Right now, I think I can make this fit, so I'm keeping this design somewhat conservative. I think this will make it less likely to kind of derail around the capstan if this ends up wobbling a lot side to side on the spool as it winds. This also is something where, you know, if I need to do something to proactively help this wind in a nice pattern, if I can't just rely on the, you know, the geometry of it to do that on its own, then maybe one of the ways that I do that is by modifying this part. So this wider idler here is also potentially a placeholder for a better spool winding component later. Whereas this idler, its primary job is to keep the cord pressed up against this capstan just a little bit. So if you imagine the cord, it'll come off the spool here, it'll get centered by this idler, then this idler will push it up a little bit up against the ridges on this capstan, so that ideally this capstan rotates at the same rate that the cord is moving through the system. So even, you know, the cord will stretch and the robot will wobble, and so this won't be like an absolute position for the robot, but this will be a better feedback mechanism for the motor than if I had the encoder mounted on the spool, because down here the diameter is going to be changing quite a bit, and I think this will be overall a much more useful feedback mechanism. And then also, in the name of feedback, this load cell is for providing force feedback, which may or may not be necessary. It's a little bit of an overkill feature. I think it'll be somewhat useful for safety and somewhat useful for balancing the forces on the, you know, the 4 cords that I have this robot on, because it's a little bit, you know, it's a 3 degree of freedom robot with 4 wires, so I want to be sure that the control algorithm can ensure that none of the wires go too slack, otherwise they might get tangled as they try to rewind. So I think that might be helpful. It might be helpful for obstacle or kind of other error detection. So maybe not the most necessary feature, but I thought it would be helpful and interesting to experiment with, so that's why the load cell's here. And then this pulley, or this idler here at the end of the load cell, is actually the last one before the cord goes up to the ceiling, where there's a final pulley that actually leads back down into the space. Oh, let me catch up on chat a little bit. So don't you want to use 2 bolts to have vertical stability? Oh, yeah, so I don't actually want... I was thinking about that, but then I'd have to design the mounting plate to have a lot of different orientations that it could go in. I think what I actually want is this bolt to provide most of the structural stability, and then to counter the rotation, I think I just want to mold some little ridges in the interface between this and the mounting plate, so that I can like rotate it, and then like once I've got it at the angle I want, I can tighten the bolt and it stays there. So I think that's my plan there. It would have been nicer for all these axes to be aligned. So for example, you know, in an ideal world, the center of gravity of this whole thing would be a little bit below this bolt, but right directly below it, and the cord would be exiting well above it. And then what that would let this do is the tension of the cord would just automatically center the winch. That would be nice, but the center of gravity is not really subject to my control unless I want to make the enclosure way bigger, because right now the center of gravity is basically the middle of the motor, which is this little mark right here is the motor center of gravity. So it definitely needs to be well below this for me to have any stability with this hung on the wall. And then this definitely needs to be below that, but yeah, the actual distances aren't what I'd like. But I think it'll do just fine. So I think that's my plan. So we've got the actual path for the cord here. We've got a few, so these 3 M6 bolts are for structural stability. You know, these 2 specifically are for the winch cover, and this one's for the load cell. Then, as far as non-drivetrain components here, this is the actual motor driver breakout board. This is at the top mostly because I had some space there, but also because that'll be a good place to put some vents to let the heat out from this heatsink. There's the cheap e-stop switch that'll let you turn this off. This is the microcontroller board. I reoriented this a little bit. Previously I had the connectors that were interesting up at front. Now the RJ45 network and the power connectors are up at top. My idea there is that I'll have a cutout at back, so the cables plug in here, and then the wires will actually kind of drape around back here so that that'll act as a strain relief. Oh yeah, definitely, as Piotr was mentioning, the dynamic loads of the gravity versus the strain tension, yeah, that's definitely something to consider, and there's a good amount of both of those, I think. So I want to make sure that this, like my goal here is that the bolt provides like some really solid compression strength to hold it against the wall, but then to keep it from wobbling up and down, that's what this kind of plastic interface is going to have to provide, and I think that'll be fine as long as it's wide enough. So in fact, the very next step, I start to add some of that. So this is the work in progress outline. So I'm no longer worrying about it being flat on bottom, because I don't really care about having to sit it down on something now. So now it's attaching with this bolt. There's plenty of screw threads there so that the plastic holding that can be pretty thick, or the metal plate, or whatever that ends up being. This back here is where that textured interface would be to hold this. But as you can see, this line right here is all totally flat, so that would make a nice interface. I'll probably put a circle on there, on that back face once it's extruded, and use that as the actual kind of clicky interface. And then down here around the spool is just a circle with rounded edges. I also wanted a flat on the front. It doesn't really need to be flat, but that makes the emergency stop button easier to mount, and I think it looks good. And then another curve on the top. How did I design this curve? I think these are just 3 tangent arcs, and then I started playing with the diameters until I got something that was both mechanically and aesthetically all right. I think if we edit this sketch, we can take a look. Yeah, so I set these distances, I set these radii. This is just set to be tangent on both sides, and then I think everything else is constraints. So yeah, this is the interface that's actually providing the attachment to the wall back there. I think Tuco wants to go outside. So then I extrude that, give it a good amount of room to hold both sides. Then I made it a component, gave it a little bit of rounding. Then, what is that? I think I'm making a construction plane where I'm about to split the case. So this is something else that I'm changing versus the last design. So in that rendering I had before, it's on the back side, but you might be able to see the lid is pretty thin on that side. I thought that would be convenient. Actually, it turns out I think the opposite is going to be the most convenient. And making that, this is the lid, and the lid is actually going to be pretty thick. And I think what I want is to have access to the set screw in the spool when the lid is off. So that's mostly where this plane is coming from. So with the lid off, I can take the spool off, and then with the spool off, I can take those screws out and take the load cell out. And so you can see that's kind of how this needs to disassemble. This plane is also below the load cell, so the whole load cell can come out once these screws come out. So that's how that plane happens. And then I'm actually splitting the body. So now I've got 2 separate, if I go inside this enclosure component, I have the enclosure proper and spool cover. And the very last step I've got on here was to, I think, hollow out the spool cover. Yeah. So then I was thinking about different design techniques. I'm kind of used to working where I just start with kind of a solid block of material and then cut out anything that needs space. But this is such a large piece that I started thinking it might be easier just to start with a hollow shell and then add back in the material that I needed. And so especially for the cover doesn't really need that much. So other than, let's not spill the coffee. So other than a good solid mount for the spool here, and for these bolts, and a good lip that will hide the seam nicely, This piece doesn't need that many features. Well, and some cutouts, maybe. The other half, I think, I was still debating about whether to shell it and then add back in features or not. I think I was still going to shell it, but I think I realized that I wanted to do the cuts to separate out the cover for this microcontroller piece first. So I think that brings us up to present day. Skipping, explaining all the CAD that I did off camera. So yeah, we'll be working on this piece, and let's also make this not metal. I'm going to be doing this two-tone probably. I haven't really decided exactly what, but let's just do that for now. Give it two different blues. Hey, Tuco. You're such a pheasant. Oh, nice. Mr. M in chat says, I'm working on a tank Wi-Fi 360 cam for control. I love working in bare feet. Yeah, me too. Although they spelled it like bare feet, like the forest creature, which makes me think I should get some bear slippers, and that might be fun to work in. Hey, Tuco, you want to bring that over here? You're just going to nuzzle it over here with your nose. I guess maybe I'll pick it up. All right, so I think I want to do this roughly like I did before. Although, I think maybe, so here's the dependency tree I've got. I want to hollow out this piece so I can start adding features to it. But before I do that, I want to make sure all of the removable parts are separated because they need to be hollowed separately. And so I want to separate out the microcontroller access door. And now I'm thinking about how big the access door should be. I think the access door needs to continue all the way across this front surface so that because I don't want these ports to be accessible normally. I want this front face to be smooth, but I want it to be easy to get access to the debug port just by taking one component off. So I want this thing to be basically safe to operate from a mechanical standpoint while still having the electronics exposed for debugging, since I think that'll be useful with curious cats around while I'm working on this. Hey, Tuco. He's been a chill little fuzzin' this morning. I think he's going to want it up in just a sec because he's in a prowling sort of mood. So I can just make a sketch on top of here and separate off this door in just a sec. But then I was realizing there's something else I've got to do, which is I need to make room for these connectors to exit. And so that actually, I think, might just end up being a cut across this whole surface. And so I think I want to actually undo this fillet until I get that part right. But, all right. So let's actually, and that's the same fillet operation that's operating on the other half, which is a dependency of this shell operation. So I'm going to delete the shell and the fillet and come back to those in a sec. But I'm going to keep the splits. So I'm going to do the splitting, then do some fillets. Well, I want to do the fillet before splitting this door. Okay, but anyway, there's a lot of stuff to do here, and it all happens in the right order, or things get really sad. Hey, Duke, you got a bolt? You do. You're so good at this. Guy. I know you just put it down. Oh, thank you. Alright, so for this, I'm going to start a new sketch on top of this. Oh. Let's also be... So I'm gradually getting used to how the components in this program work. I did actually take the plunge of taking one of the things that I was working on in a separate file and merging it directly into this file. So this... What was it? This measurement assembly thing used to be in a separate file, and now it's a subcomponent. Which seems... I don't know, I still haven't quite got the hang of starting something new and having it end up completely self-contained inside a component. Because the workflow I'm used to at this point is I make something in the kind of main component, like the parent component. I make something with like a sketch, so like a 2D sketch, and then extrude a body from that or whatever. And then I can move that body into a new component, but the sketch I made it from still stays in the parent. And so I'm not really quite sure what to do about with that. This other workflow where I make something in a totally separate file and then just place it and then unlink it seems to work all right. But I don't know. So I think here I'm just going to do a sketch on top of this and cut away some of this surface to make room for connectors. And so actually, ideally what I want this to be is room for the wires to plug in up here, and then actually an entire channel that lets the cables kind of fall down gracefully on the back of the robot. This is also starting to get slow. I don't know why. I don't know. I'm getting frame rate bogging down already. Maybe I should turn down the screen resolution. So I want to project some geometry. I want the edge of the circuit board, I think. I want the edge of the mini USB connector, or micro USB. This color scheme is so invisible, it's like, how would you like to select some lines that are dark blue on darker blue with black edges? Hey, Took. Try to turn some of this stuff off. Okay. Hey, little rambunctious kitty, you want to play fetch still? That is a huge yes. It's the biggest yes I've heard from him this morning. All right. Oh, my coffee's already getting cold. So we're going to want to work with the outline of the circuit board and the USB connector because it kind of sticks out. And let's also think about the Ethernet connector. Let's just project those faces. And then we've already got these edges. And then just thinking about, well, what can we cut out? We've actually got a lot of room that we can cut into. The main thing we've got to work around is the edge of the motor. So I want that for reference too. So let's just do that. Oh, and it got slow again. Maybe we can turn off some of these things we're not using. I still wish I could group a bunch of these things into, I don't know, like, I feel like I'm so annoyed that groups in this program don't work like I would expect them to. Maybe I want subcomponents. Like, okay, maybe let's take a brief diversion to solve an organizational problem. So I've got just all this junk over here. Chico, are you making a mess looking for bolts, like usual? Chico has been digging into my pile of very delicate load cells, looking for bolts. Maybe I'll put these on the desk. Chico, these are delicate and ESD sensitive. I know you're looking for bolts, though. I support you in this endeavor. Oh, is that a bolt? No? Where's your bolt, little guy? Oh, there we go. slightly wider angle camera helps. Hey, little fuzzit. Where is it, little guy? Oh, here it is. You were just sitting on it, or I was blind or something. All right, Took, you ready? Oh man, that's a great quote from Vincent in chat, who says, another classic quote. It's the wild color scheme that freaks me out, said Zaphod, whose love affair with the ship had lasted almost 3 minutes into the flight. Every time you try and operate these weird black controls that are labeled in black on a black background, a little black light lights up in black to let you know you've done it. That is pretty much my experience with Fusion 360. Yeah, everything's 16 by 16 pixel icons and 10% opacity. You getting a little dude? Oh, I'm also surprised Piotr says that they're sure I know what I'm doing with the mechanical design. I don't know about that. I'm very much an amateur mechanical designer. I've not done a lot of this, but I think projects like this are great for learning. Especially if you test it along the way and, you know, try to build in enough safety features that you don't hurt anybody. Then I think things go all right. How much space do I have here? Because that's a little tight. Six millimeters. So I probably want about a 2 millimeter wall around this motor at least. So that would leave me about a 4 millimeter gap for wires just in that section. Which, if this were the wall, then that would be maybe a problem. But I think I'm actually going to have a corresponding gap on the back plate also, because, you know, if we're thinking about that load-bearing region, like that circle around this bolt, I don't think it's going to extend that far this way, so I think we can have a corresponding cutout on the wall mounting plate, and then like a little bit of a loop to help corral the wires as they go down. So I think this might be enough. So let's make... Okay, back to the... Let's try not to get distracted. I was trying to organize this stuff so I could improve my frame rate. So I have... Can I organize the electronics? So these are 3 circuit boards. It'd be really cool if I could group these together somehow. Is this a selection group? Is that what I want? Because if I made these all one component, then I think that would interfere with the way I have the joints laid out, and I don't really want these to be joined as a component. I just want them to be easy to manipulate together. I don't think create group is what I want. I just clicked create group and I don't think that did what I want. I don't think it did anything actually. Because there's nothing in the undo list. Can I create a selection group if that's what it's called? Create selection set. I think I just, oh yeah, it showed up here. Oh, maybe this is what I want. Maybe this is how Fusion 360 helps you manage this particular brand of mess. They don't let you actually clean it up. They just give you another thing to use. I'm going to label that one circuit boards. Then I can click that and select them all. Can I hide and show them all? Because that would be really nice if I could hide and show everything in the selection set. because this selects everything. But if I click on one of these light bulbs, it just hides or shows that single item. Wouldn't it be really common to want to hide and show groups of things together? Like, this feels like I must be missing something. This just seems like something really, really basic. Wow, it doesn't feel as slow anymore. Maybe it's my imagination, or maybe it cached a bunch of stuff. But I'm going to complete this curve around the motor because it didn't have this one in the projection. And then can I get an outline? I can. Cool, so I think this wants to be like 2 millimeters. I know that doesn't make this distance 2 millimeters. Actually, maybe I do care about that distance more than I care about it being an outline. So let's just make a vertical line here. And then dimension this as 2 millimeters. So then this, if we were just to take it all the way down, it would kind of cut that at kind of a weird angle, which might be fine. We could smooth that out though. I don't know if I want to, I could also cut out a lot more of this space, but I think that would make the overall visual design just look kind of weird. I don't know, I'll figure out what to do with that side. Let's focus on this part. Let's have another line. So I think this one, how much space do I have to work with here? I think the end of this connector is going to end up ending kind of inside the plastic wall, which is probably fine. Because I think the wall thickness I need is thicker than this distance. Let's measure that. Measure the distance between these. Can I do that? No, that's not what I wanted. There we go. Yeah, that's 0.7 millimeters, which is not, like, I think the clearance between the circuit board edge and the inner edge of this enclosure should be a little bit less than this, but then the wall of the enclosure is probably going to be like a millimeter here, so. Let's mock that up then. So this, we'll call this the inner edge then. Are we modeling the inner edge or the outer edge? I thought we were modeling the outer edge. This piece is definitely the outer edge. Yeah, let's not worry about the inner edge yet. And if we're making that the outer edge, then let's call this 1.5 millimeters. Oh, is that trying to mark that up as an angle? What is going on here? Another line down there I didn't even want. Okay, these need to be parallel before we can dimension them. So I think 1.5 millimeters. Yeah, that'll give me enough room. Like if this is the exterior edge, this will be a little bit buried, but the end of the connector will still be inside of this if I make it a 1 millimeter wall. I think 1 millimeter is maybe too thin for that wall to be, though. Can we just make this entirely 2 and shave the middle a little bit? I think I liked 1.5 better. All right. And then if I take this over, how does it interact? Can we keep the dimension on this side, please? So that could just come to a nice rounded edge around the back of the motor. So the circuit board and the back of the motor are lined up. And I could even put a little circle here to make it a fillet. In fact, can I directly just fillet these two? Is that a thing I can do in this program? I know Rhino can do this. I can. Nice. Need to be a much smaller radius than that, though. I think we can take 4 millimeters. And then what is this like up here? I think we can extend this all the way up. So that's one potential bite we could take out of the case. Now I'm thinking about what to do with these edges. I also don't like how thin this is, but I think it's probably fine. I think I can make this thinner. This is only at the very point. So like for structural reasons, it's going to be thicker everywhere else. This is just like, I don't know, let's try a millimeter. Like this point right here is where it might not print a very thick wall if we get this wrong. Let's look at it orthogonally. I'm happier with that. Let's think about these edges now. Kind of want to blend these in. In fact, I could use this as an opportunity to make something that cuts out this whole bottom section, which wouldn't be necessary for the wire relief, and I'd want to avoid, well, I don't know. I was thinking if I made this too much of a curve forward, then it would look weird having the wires just go straight down, but I think that's also something that I can have a lot of influence on with the design of the wall mounting plate. I don't think I want this to come any further forward than that. I kind of want to round this interface, though. Can I fillet these? Is that a thing I can just do using the built-in fillet, or will I need to do that more, oops, more piece by piece? I guess I need to project this first. I don't think that's the problem. Maybe I use an arc. Tangent arc to the rescue. That is not tangent. Why is this not a real object? Okay, I can make them coincident. This is just one of those objects that has the weirdest selection properties. Okay. Great, now I can adjust this. And so this is just going to be aesthetic. I mean, doing that removes more material. Might also just make this look weird. Let's maybe set the radius. Do it that way. I'm not sure why this isn't a profile anymore. Oh. Does that help? Yeah, okay. I don't really need that much of this space, but I want to keep this front pretty square for the button and all that. And I want to keep this curve consistent on the front edge. So I think that's all that's doing. Now for the bottom, I wonder if I can just take the same curve radius and move it up some. So let's take that out again. Do we have the center of this? Where did that go? There was a center point for this somewhere. I'm not quite sure how to select the center of this. Maybe if I'm making a new circle. Is there anything around here I can select? Why is this so annoying? I mean, I guess I could find the center of this geometrically. Can I make this? Oh, right, there is no perpendicular constraint. So even finding the center geometrically is kind of annoying. I have to make 2 tangent lines. Okay, I have these 2 construction tangent lines. Make another triangle. These need to be perpendicular. And I think they just now also need to be on the circle. And now we have the center. Okay. Thanks, geometry. You're the best. Now what I want to try to do is make another line here that is just a construction line vertically. Make another circle centered on that. And then I want to try setting these to be the same radius. So now we have an identical circle, just moved up somewhat. Why do I have an hourglass? Okay, there we go. Yeah, it doesn't look like it's the same radius, but it is. And then I can move it up. And then you can see, like, I could just keep moving it up until I'm about to run into some internal hardware, which is like right about there with the motor. So that's actually how I could position this again. I could project the motor geometry up to this and then set a distance. I think I need to make a line. All right. And again, I don't think I can do perpendicular lines. I think I can just do tangent lines. Oh, this color scheme is terrible. So these are perpendicular and construction. This one is on the circle. And this one is tangent. And now I have a distance. Let's actually make this the length of the curve instead of the orthogonal distance, maybe. Yeah. And this also doesn't need to be that much because we're going to have a lot more mechanical support in pretty much every other part of this. There's no screw down there. So let's just make that, I don't know, 1.5 millimeters. Then that is also not quite a straight vertical shot there. Maybe I end up replacing this whole thing with another arc. And then on this side, oh. Is that straight on that side, or is it also a bit of an arc? Okay, cool. So that is vertical, and that will just meet up seamlessly. Yeah, so that's actually really close. I think we just got to focus on this edge over here, and then we've just about got a shape for this cutout. Let's do some trimming. Well, let's get this connected and then do the trimming. So this piece, I think, is going away. And then tangent circle to the rescue, I hope. So one thing I don't like is when you zoom in, a lot of stuff doesn't actually get bigger. Like sometimes I find myself zooming in not to get closer to the design, but to get close to the tiny icons. Did that not work? I guess that doesn't work because it's another curve that's also pretty under-constrained. Maybe this does need to be a line, it just will not be a vertical line. Let's just use that as a stand-in. Restore the tangent constraint here. And then what if we just make these tangent? Where does the solver take me? That seems like an alright place to be. Yeah, let's do some trimming. I think that leaves us with the parts we want. Yeah, let's try that. And how far down can we go? Not that far, clearly. But, well, so how far do we need to go? We need access to the circuit board's connectors. And now we're starting to eat into the encoder. I can move that power jack. I need to see the insides. Come on, download it. I think that it's like waiting on the cloud to send me the rest of the geometry. Oh, or is it just not going to do that? Did I hide that? Oh, I did hide it. Cool. My fault. So that power jack can go a lot of other places. Oh, maybe I need section analysis to see inside this thing. Where do I have a flat surface? The XZ plane. XZ will do fine. So this is the potential cut that we're making. Oh, there's supposed to be more stuff in there. Where is the circuit board? Is it just drawing all of that in yellow on yellow for some reason? Section analysis is less useful when the parts are all overlapping like crazy. So let's cancel that. Can I just go back into wireframe? Well, the only thing over here really is the encoder. I can't really move the encoder, but I don't think I need to. I can just take it down almost that far. And I can find a different place for that. Maybe over here. So that would be right to the top of the encoder. Let's give it maybe 3 millimeters above that. That's a 30 millimeter cut. Alright, so everything is still overlapping and terrible. But now that's a bit more of what that's going to look like. So big old spool on the right side, kind of smaller cutout area on the left side. And I can smooth some of these rough edges too, a lot of fillets. The power jack is not in a good place, but I think over here between the circuit board and the e-stop would make a great place for the power jack. That would probably mean the cable sticks up a little bit. So what about, well, this space is going to be taken up by the motor, I think. Is it? Let all the parts render. There's the motor. Yeah, the motor is right there, so we can't really put the DC jack. And that's going to be up against the wall, so there might be room for it if we move it up a little bit, but that seems too tight for comfort. We might embed it in this surface and have it come out that way, but then that would make the wires bend in an annoying way. I think it just goes up here, and maybe it sticks up a little bit, but that's fine. So this is set by a joint that we're going to have to go back and find and edit. Did I label that one? DC jack. Yeah, this is the joint that's connecting the DC jack to... So I'm using the face of the RJ45 jack as a reference here. Maybe I actually just want to make this simple and use this other... Maybe I'll just use the center of the RJ45. Make that 0 millimeters. That's 24 millimeters between the DC jack and the RJ45. 20 millimeters. Is that cutting it too close? What does 25 look like? That seems like the power connector is going to be sticking way up. Oh, Alfie is asking if I saw my message about the DaVinci. I assume this is the Blackmagic editing software. I did. I haven't really looked into it that closely, but it's on my list of things to try. I just don't know that I need, like, right now to be the time that I switch editing software, but it's been on my list of things to do pretty soon. Oh, and then Robert was talking about the Z-fighting. Yeah, that's just because I haven't cut out that hole yet. So it could go there, that'll be fine. That would be kind of prime space, but that's where the motor goes. It could go just above the circuit board here, but that would make the circuit board hard to get out. I could put the circuit board in the other orientation, and the RJ45 jack would be on the other side. And then I could sneak the DC jack a little closer, but then the circuit board would be harder to work on because I want it to open up on this side to be easy to access. And also, I mean, if you imagine I'm about to put a door in here, I don't think the door needs to give access to the DC jack. I think the DC jack can just be wired in from the other side, and it'll just go directly to the e-stop and then the motor controller board probably. But I want pretty easy access to this part. So just having like a stripe here that comes apart would be nice. But I could actually split it here and just make the case like a 3-piece sandwich if I wanted. I mean, that's compelling in some ways. Because if I did the stripe thing again, that looks pretty cool, but it would make this piece annoying to print probably. Whereas if I sliced it right here, then I think printability would still be pretty fine. That would be a little annoying with the e-stop button where it is right now. I'd probably want to nudge it down a little bit. Do I have room to do that? Yeah, I think so. This is just me wanting to move the e-stop button a couple of millimeters left so that it doesn't have a mounting, like it does. I don't want this to be holding the two halves together as it's mounted. Oh, Tuco's sitting right next to me. I should bring the camera over. Also, FYI, I know that this project is still deep in the minutia of designing mechanical bits, but I did go ahead and set up the streaming for this little camera. So if you go to twitch.tv/TucoFlyer, it won't actually be robotically controlled or whatever, but you can just get a stream of this camera whenever you want. It's currently pretty experimental, but using this to test out the streaming infrastructure. You can see it's on a little bit of a lag. There might be some ways to increase or to decrease the latency. Right now, the video is going through Nginx on my side instead of going directly to Twitch. And the Nginx is where I would do things like screenshots and announcements, but I don't have any of that stuff set up right now, so maybe it can just go directly. Yeah, I'm starting to like the idea of this just bolting together in 3 pieces. So how do we move this? And what is this going to get stuck on? Is the section analysis going to help us here? So that is the main M8 mounting bolt. And that's the output pulley. So I was giving this kind of some generous clearance between this and the output pulley, but I think there's still plenty of room. So I can just move this over by a few millimeters. Oh, and so I was also having trouble figuring out, like, oh geez, this project is huge. Where do I find the one joint that controls this? So I think the way to do that is to click this, and then if I follow the little stripy highlights, I can see that this is the emergency stop dummy module here. And if I right-click on this, I can select referencing joints. And there we go, e-stop joint right there. So then I can edit this joint. This is also pretty nice because I think this is showing me, yeah, so the two pieces involved are the mounting bolt here and the e-stop, and I'm just setting the position of these two relative to each other. So it looks like there's actually plenty of room to just nudge this over. Maybe even a little bit more. Eight millimeters. Yeah, that seems all right. And let's see what happens if we just split this again, because yeah, I think this might be nice coming apart right there. How would we hold it on? We can just add some more screws. So we'll have a center kind of load-bearing part and then two halves that kind of plunk onto either side. All right, so now enclosure has 3 bodies. I'm going to call this core, spool cover, micro cover. And this I'll probably also print out of the other shade of plastic. It's starting to look like that. And this is looking a little bit visually weird on front. Like, this coming down is kind of strange, but there are going to be wires coming up right here, so I think that'll aesthetically end up looking just fine. Plenty of space for the e-stop. The cord's going to come out through this half. So one thing that this means that would be slightly annoying is that, well, I guess I could just make this kind of a large cutout. I was going to say that this would involve threading the cord through this half of the enclosure and then onto the wheels, but I think it's probably a better idea if I just make a U-shaped cutout here so that just give it like a really oversized place for the string to come out there. Since I really don't want that rubbing on the enclosure, nor do I want to have to thread it through the enclosure. I think the thing to be doing now is to be looking for what do I do before shelling these features. And the middle piece, I might not even shell that, or... yeah, I'm going to shell the middle piece. Because if you imagine the middle I can start with this as kind of like the closed bottom piece, and then this open, and then kind of work on it from there. Just treat all of these kind of like they're containers with one side open, and then start adding and removing things. Before shelling, I want to do the fillets so that I have a consistent wall thickness. Maybe let's try filleting, and then I'll remember if there's something else I need to do before the fillets, and go back in the timeline. That's gonna be a problem. just gonna see if I can make these all uniform. I don't know if this is actually what I want, but let's see what this looks like. That won't even calculate. Okay, let's do these piece by piece. So in here, the critical dimension is going to be this corner of the spool. We'll need to leave enough room for those corners to have room to wobble a little bit inside. Let's see if I can go sharper. 5mm looks pretty good there, actually. So what about this one? Five again. I mean, I can go a little deeper, but I think that's nice for consistency. It doesn't need to be too smooth. And then we've just got a couple of these edges, which are going to be trickier. Actually, this I probably should have filled it before I split this tool, or split this body, so maybe I go back. Alright, so this is still one piece. Let's fillet this. Can I do 5mm? Split. Fillet, fillet. Cool. That's getting closer. Okay, now for some hollowing these. So I was going to try to use a 2mm wall thickness, which should give me a pretty sturdy but not overkill part in most of these areas, and then I'll add reinforcement where it needs it. Is it having trouble with this, maybe? Well, I could just do this manually. I mean, the core piece, I might end up just having to take stuff out of myself since this is a little bit more load-bearing, and maybe I want more of it to be solid, so let's leave the core alone for now. Spool cover, micro cover. Let's try this. Is this one also having trouble? Oh, there it goes. I think it might have still had some geometry from the other component in there. So that's a little nicer. We could cut out some connector holes. I think think that DC jack can be a little closer. I really want to move that by an entire 5 millimeters. I really didn't want an entire 5 millimeters, guys. Not 202 millimeters, 22 millimeters. Cool. Yeah, that at least keeps it on the completely flat part of the case, which would be nice. There's a nut that goes on the outside of this jack. Oh, what is this? That doesn't seem right. I think I had a problem with my cutout here. Let's go back and try to fix this before this gets worse. That was not supposed to be a ridge right above the RJ45. I think I selected a line that I didn't mean to. There we go. That didn't really disappear when I stepped back, it just moved into a body that I had hidden. So I think it's this extrude. That's better. Extra bit of stuff selected there. Of course, this fillet needs a little help now. Cool. Okay, I think it might make sense to look at this without either cover now and just looking at the core. Oh, circuit board is just kind of sitting on top a little. So I'll have cutout for that board and some standoffs for this board. Cutout for the motor. Some more support for the motor in the other half, I think. I start drilling holes in this. Hole. Face. I want to mark. Oh, is that gonna work? Oh, cool. I think that is what I wanted. And first, let's do an 8 millimeter hole all the way through. It doesn't like that depth all. It's also very much not lined up, is it? Can I just do this? I don't know about holes, man. This really doesn't seem to like depth being set to all. But if I just manually drill through everything, then tell it not to, don't touch the nut, just drill through the enclosure. I think that was what I wanted. But that didn't help a lot because I still need to drill the clearance hole for the screw head, which I think this would all just be easier to do with a sketch, so let's just delete that. Oh, Joseph is asking in YouTube chat, what's your plans for this thing anyway, just for fun? Well, I hope it'll be a lot of fun. I mean, is anything just for fun? I mean, my plan for this thing is to build... So, I mean, the overall project is to have an interactive camera for my CAD. And so, I don't know. What does that mean to you? Is that fun? Is that the meaning of life? Somewhere in between? Well, if I make a sketch here, I can use that for a few different things. I can use it for, for the mounting bolt. I can use it for the e-stop. So I'm just going to call this... Oh, I'm forgetting something else. Let's not create this yet. I should be doing a bunch of this stuff inside the enclosure component. So there's this whole notion of an active component now. I guess this stuff that I was doing already got sucked into the component. So I still don't have a great sense of how the object model for this program works, insofar as like when you do some action to a component. Like how are things stored? Like, are things stored based on the bodies that are produced or based on the actions that you took? Because now I just made this component active, and even though I did a bunch of these things like the fillets and the shell operations while I had the overall component active, these operations seem to have been stored in the smaller component. So I don't know. Oh yeah, so I guess Robert, who was asking about the Z fighting earlier, yeah, this is just a work in progress, and so these parts are going to be largely hollow, but that just hasn't happened yet because, in thinking about it, it's easier to design the outline to enclose everything I want and to have the right shape, while keeping some, kind of an eye toward how things are going to be attached, and then go back and hollow them out and add the attachment. There are a lot of different ways to do it. This is just what made the most sense to me for this project. All right, I'll see you later. Sorry? Yeah. All right, well, I think this is a safe time to make that sketch. Want that to be on this front surface. Project some stuff for reference. This is one I'd like to just pick it from this list here. But highlighting stuff over here is not, just doesn't seem to highlight it out there. That's what I want. Can I project that? Error. Wait, it just gave me a long, complicated error that then immediately disappeared. Projection of the selected spline or curve would result in degenerate segments. Okay, so maybe we don't project the screw threads, but I'd still like to have some kind of reference for where the screw is. I really don't like the selection mechanism in this program. Okay, there they are. Okay, there it is. It was hard to see, but there it is. I also want to project the part of this that needs a hole drilled, which I think is this center part. Let's measure this. Yeah, 22 millimeters, that's right. Okay, so I want to make, well, let's make all of this construction geometry. Oh, geez, I'm not even in the sketch right now. Modal interfaces. Okay. Construction geometry. Now I'm going to make a cutout for the e-stop. I want it to be a little bit larger than 22, maybe just 22.1. I think this one tends to be a little undersized anyway, so. And then for the bolt head, I think the bolt heads themselves are, it says 13 millimeters. I want to make kind of a generous cutout so I can get a tool in there pretty easily. Just add a whole millimeter of clearance and make that 14. Or 15 if I want a whole millimeter on each side. And then for the actual screw, I want that to fit kind of snugly. So let's just make that 8. Maybe 8.1. So that cuts through everything. And don't go away, we got more work to do with that. And this is the one that will let us actually have access to the screw head. I think that's what I want. No? I don't think it knows what I want there. Maybe I'm just gonna have to do this with distance. I also really want this to cut the center also, even though that's already cut out, but this is just geometrically looks much nicer. Alright, that'll be fine. Making this a tiny bit longer is not a big deal. That'll just give the screw a little bit more room to seat. What happened there? That's what I wanted. Okay, and that's clearly going to need another cutout that this ends up mating up with, but that'll be enough to get this started. I think it might just be time to make a big old sketch that fits on this face. Core interior. Let's label these more carefully, because I'm going to want sketches on both of these sides. This side is probably where I'm going to dig out the motor, although I want a little bit of margin around the motor. Can I just offset a surface here? Be named. Maybe I'll just cut this. Target body. So that's just what happens if I just do a Boolean cut with the motor. Which makes me slightly uncomfortable because it doesn't include any additional tolerance, but it does give me the shape of the motor the way I want it. So maybe I'll start with this and then just add a little additional tolerance by kind of cutting at these surfaces a bit. I guess if we're playing that game, I might as well cut the other part of the body too that's sitting in. Well, the other part's already shelled, so it's just going to fit over that, so I'll worry about that later. All right, so here, let's cut out space for the spool. I need the center again. How do I find the center? There's got to be an easier way to get the center. Point at center of circle. Great. That was the easier way I was looking for. Where did that just go? Oh, geez, what is that? That is the most invisible point. It's not that. That's something else. What the heck? So hold on. Project this. And then let's clear some of this stuff out. Oops. So, yeah, I think what I did here, well, I want to leave plenty of room for the spool, but I think maybe I'll actually set the wall thickness here. Two millimeters. Huh, what are these two different lines? I think that's the real one that I projected. I don't know what that other one was. I think I just want this to be, I don't know, like I already made it coincident with the origin here so that it would keep this perpendicular with the circle. I guess I could just set that there. This stuff, construction geometry all the way. Let's turn the spool back on. Okay, that's what we're doing. Cutting out this bottom area. Oh, I see. That might be a reason for that distance to be a little greater, to give this screw a little more room. The wobble that I'm worried about on the spool is more like in that axis rather than, in and out. The spool is not going to change diameter. So set this to 3 millimeters. let's not cut the spool also. All right. I think that's how far this comes down. This comes down to right below these screws, if it can. Why didn't that work? I had to change the chaining mode. I still don't quite understand the difference between chain faces and extend faces. I think chain faces does something magical, while extend faces operates the way I expect an extrude to work. Okay, there's without the spool. It took me a sec to actually figure out how to turn that off. So we just have the bolts holding the motor on, and some space for the spool to just kind of hang out in. The rest of that is mostly going to be structural. Okay, and this is going to want some more reinforcement. We can duck into the spool's area, kind of in this axis. So we could do something a little bit special up here with the load cell mounts. This also pretty much sets the printing orientation, so we're going to look at the bottom here being on the print bed and try to keep that such that it works. We might end up having to fill the motor cavity with support material. I'm curious to take a look at this in section view to see what the thickness is like. You can see the circuit board still needs a bit of a cutout on that side too. We can clean this up. I don't think the motor is going to sit in this very, very snug area. I think that's probably fine, but I want to add some... Well, we also need to keep track of where the wires come out on the motor. Here's one of the motors. Big old heavy 24-volt thing. So it looks like if I place this in the orientation it's in on the screen, the wires are coming out kind of right over there, which is actually just right, because that means they come out into the part of the enclosure that's just kind of a hollow shell for the most part. And we can put support ribs in there, but we can just kind of avoid this area with the supports, and I think we'll be good. So I'll leave a lot of that in place, but I think I can trim some of this stuff. First of all, motor mounting holes. This thing is not useful. And generally just going to open this up. That might be too much. I mean, I still want this to hold the motor relatively snug. I just don't want to over-constrain anything here. So maybe I'll just open up each of these by like a 1/4 millimeter and try not to overdo it. Maybe a 1/2 millimeter. That seems fine. Similar treatment with this edge, maybe. Just opening up that motor cavity. Right. Still don't really know how the top is attaching to this, but I think we can save that problem for a little bit later. And this definitely needs a little bit of room. There might be other solutions, like just moving this up a little bit, but I think I also don't mind just cutting these out. I'm just kind of working on whatever I feel like at this point. There's just so much to do. Just making another sketch on this rounded side. And I'm going to focus on supporting this board a little bit. Yeah, I don't know what to do about that, because if this is going to be the print side on the bottom, I really need to limit what I do on this side. And some cutouts would be fine, but mounting standoffs really wouldn't. Now I'm wondering if I should split this yet again and have the core have 2 halves. Because I could see maybe splitting it like on this plane, like the bottom of the motor mount here. I mean, if I did that, these 2 halves would probably not be designed to be disassemblable, really. Like, I might just make them 2 halves for printability, but then they're glued together, or just, I don't know. But then I'd have another seam running down the middle. How else can I mount the circuit board? I mean, I could have everything mount into this side and then just wires. I just like the idea of this part being something I could easily just take off and run without this enclosure on. Or, without this part, this side. Now I'm thinking about other print orientations. I mean, I want this to be printing in this axis for strength, I think. I can flip it. I could also just try to make the circuit board mount really low profile so that it can still exist on the bottom of the printout. Like, I could use separate, like, brass standoffs or plastic standoffs and then just put holes in this side. And then, as for other electronics, this will just mount in a slot, which I can print pretty easily in whichever orientation. There's going to be some hollow pieces, like more of these. Maybe splitting it here is still a good idea, but then I can do something to hide the seam on the edges. I don't know that that works, though. I'm curious about the splitting, though. Let's just look at what that would be like. So now we would definitely be printing with this side on the print bed. There's still a little hollow for the motor, but that wouldn't be too bad to fill with support material. Then this would be all chunky load-bearing stuff. And then the other half looks like this. And we could print it with this side down. Yeah, I think this is the way to do it. And I can still build all the support pieces I want for these. And I think the cover that goes on here would be a lot nicer if this front piece that actually holds the connectors were actually part of this. So then I could just take the cover off and not have to like have the power jack be on there. Just catching up on chat here. So Robert suggests separate standoffs. Yeah, I was thinking about that. It's just I don't know that that's my entire problem. Like if it was just the PCB, then sure. But I also want something to hold this DC power jack. Right now, it would have to be screwed into the other half, but then now I have like a wire mess between the two halves, whereas I want that to just come off cleanly. So let's maybe revisit this. It does seem like, I don't know, I like the stripe again. Like having this just come off in this kind of a chunk would be kind of nice. Oh, Alfie says I could always use a 2-pin connector on the other end of the power tail. Yeah. I could. I'm just thinking about a better option. Because I don't want this to have like a bunch of dangling wire mess. I'm imagining that it would be nicer if I just cut this differently so the very front part of this ended up on the bottom. Yeah, I think Alfie's suggestion would work. I'm just looking for something a little more elegant. Which might be a waste of time, but I find it fun. And what is this part for? That's just to make the front flat. To hold the power jack. This space is necessary for the motor, but and as far as like a sensible location for the power jack, this isn't even the best location, it's just kind of the best available. The best might be over here, but that's taken up by the motor. I mean, I like the idea of a little slanty door that just covers this. Now I'm wondering, could I make this whole thing less tall? I think the motor is still taking up a lot of that space, though. Turn the motor back on. Yeah, the motor's taking up all that tallness. I mean, it's really tempting to just mount all the electronics to the underside of this cover, since that would be easy. Then it just means that all the wires to the sensors have to be loose until the thing is fully assembled, and I just think that will be annoying. So my inclination here is to leave this mostly as it is. In fact, I can even leave the power jack attached over here, but then just have a cover that comes off in like a stripe here. That means there might be a seam in between the RJ45 and the power jack, which would be a little bit weird. Get a lot of hate about the fillets, man. I like objects that feel good to hold, you know. And I mean, I understand that if you're doing this on a mill, then like you probably need a custom tool for each fillet radius, and it just gets annoying. But hey, man, I'm not designing this for a mill. I'm designing this for the tools I've got. Okay, I didn't make this hollow yet, did I? We're just looking at the microcontroller cover. I did make this hollow. Let's undo that, because I'm not actually ready for that yet. Okay, no more hollow. Now I'm also wondering about combining this piece with the piece right below it. Probably have to have a cutout in there for the optical encoder. Robert wants to crowdfund me a mill and a lathe. I mean, I could do that. Why do you want me to use a different tool, though? Is this a problem that I'm 3D printing this? I mean, I have a mill. It's just not big enough for this. It's a very tiny mill. I'm convinced Robert is just a manifestation of all depression in the world, and he's just trying to, I don't know, just make every project seem glass half empty. Let's maybe undo the split that separated these two components. Which one was that? That's the really recent split. That's the one I'm talking about. Let's try it. Let's see what happens if we don't split these components. That wasn't quite what I wanted. Okay, well, I just lost a bunch of a bunch of stuff that depended on that, apparently. Yeah, I just deleted a whole bunch of stuff that depended on that. Oh well, whatever. I didn't need that work anyway. Thanks, AutoCAD. Okay, I just Boolean subtracted the motor, just like before. So I think we want to make the other cut down here. Yeah, I think the next cut happens like at this motor mounting plate, which I can't really select, but let's try that. None of those. Try again. Select the slightly bluer object on the slightly less blue background. Okay, so with this cut, when I bring this down, I'll end up with just that load-bearing plate between the motor and the spool. Then on this side, I should have a nicer mount for the motor. So I should be thinking about the next cut, since apparently rethinking the cuts involves deleting a whole bunch of stuff. So if this piece, well, what am I actually working with? So I've got core. Where did this go? Oh, there it was. I just have to scroll down. Oh, and I've got a bunch of screw pieces that I don't need. I just deleted that, and it took away way more than I wanted. Apparently, if I delete one of these, it actually deletes the feature that produced it. But actually, these are just kind of spurious bits that I don't want. So I think I want remove instead of delete. Although I think I want to remove them all at once. Okay, so now we have spool cover, core, and this will be electronics mount, maybe? PCB mount. Okay, let's look at these pieces from a printability point of view again. Okay, so we've got spool cover, which prints like this. We've got core, which we haven't hollowed out yet, but it's going to print like this. Bottom plate, and then this will be carved out in a lot of ways. Optical encoder will go all the way through that. This will have to be built up a little bit. I mean, this will still need support to print. I'm just trying to make it not need as much. That seems like an okay starting point, though. Now PCB mount. So that'll print with the flat side down here or down. We'll need a little support material, rather a lot. Okay, maybe we're printing with this side down. Thinking about how to separate these. So I have a cover, and so this piece becomes kind of printable. Yeah, so I think having this flat side down still makes sense. I can separate the cover so that I don't have this bridge to make, that the motor will just be hollow there, or the motor location. Then and then I can leave this front half and then take the back maybe. So I think I want a plane perpendicular to this and then make a sketch on there. Plane at angle, I think, is what I want, sadly enough. Okay, so this will be the PCB cover separation sketch. If I could rename it. Why can't I rename this? Oh, because I'm in projection mode. So I want the motion for putting the circuit board in to be to kind of like angle it in, putting the connector side in there, and then screwing the rest of it down. And when you take the cover off, it should leave this front panel down, but still provide access to as much of the rest of it as we can. So, and what do we care about the front panel? Yeah, so I think I want to think about this in from two different perspectives. So from this view where we have the sketch right now, I want this to kind of go over and then down and then over again. And I want to think about this to make sure that the seam looks nice. And then from this perspective, I actually want to probably only to like exclude this front piece because I want this to be flat. And just go down here. That also needs room for the encoder. I've also got the space up here, which is pretty much unused. It might be nice to move the... Oh, I wonder if I can make this whole thing thinner. I kind of can't really, because the motor is really what's taking up most of this space. But I can make the strain gauge amplifier easier to access, at least by moving it over here. It's currently nestled under the circuit board here, which was okay when I was trying to save space, but is seeming kind of unnecessary right now. Where is this attaching anyway? That corner to there. Let's try there instead, maybe. I think there's plenty of space there. Let's see how that looks. Oh, DC jack. But that can go way back here. Not quite that way back, maybe? Yeah, that's a little too far. Okay, that seems nicer. Okay, so back to the sketch. Oh, this color scheme is so difficult. So this is going to be a printed part. Ideally, I don't want to have a huge overhang here. But this is also basically going to create a little lip that the other half of the case slides under. Let's try 120 degrees there. I think I need more stuff projected. Except all that's construction geometry, none of it's real. So maybe also project the circuit board. The cover, ideally, I think should come a little below the circuit board, but I don't know that it needs to. So we might cut out a little more of that, but I think the point of this, maybe this should be a little longer. That should be 6. This should be 2. So on the other side, what am I doing on the other side? Is this just going out and out and out? I think so. Just make that longer than the model. Is that longer enough? Let's make it 200. So this should be something I can extrude and then use to cut out a lid. Now one question is, how much of this do I need? This won't be symmetric. Let's just set these. Make a new body. So we don't need really anything more than just exposing the circuit board there, and maybe the load cell amp on that side, while also providing enough room for these connectors. Maybe a little less. That could be pretty cool. I think I like that so far. So then I'm going to use this to... Okay, so just to back up a bit, I've got these pieces. I have the core, which is this middle load-bearing piece, which will be mostly solid, maybe. And then hollow spool cover, mostly hollow PCB mount, and then mostly hollow cover for the PCB mount. So I need to take this PCB mount and split it using this. And since I don't think you can split using a body, I think what I actually want to do is intersect it twice, or combine twice and use and intersect once and a cut the second time. So we can make a new component by taking the PCB body and intersecting it. What do we have? Oh, here's the new one. Maybe I didn't want a new component. I think I already have the component I want. Let's actually just make that a new body. What? Now I can't see the operation that I wanted since it created a new component that was like outside of my scope. So I've got to go back here and then edit this feature. Oh, I had to make a new component that time. Or maybe I just can't change it now. Let's just delete that and try that again. Let's delete that. Go back inside the enclosure component. Now there's the extrude that we used to make that. There's the core. There's the part we're splitting. Let me try this again. Intersect. No new component, but keep tools. Okay. Great. I think that's what we wanted. Now we have this. No, not that. We still got a new component. Or did we? There's no body. Oh, well, I guess what I wanted was to make a copy of that. Maybe I just need to duplicate this part first. I don't know if there's a command for duplicate. I think the right way to do this is to copy and paste. Oh, I guess if I'm copying a body, then I know about the move/copy command, which is just what it did. I guess what I was thinking about was copying a component, which is, yeah, I don't know how to do that other than copy and paste. Okay, so we've got PCB mount now, and this will be PCB door. So PCB mount. I'm going to remove the body 9 tool, cut with this. And then PCB door. Okay, I think I just separated that. Let's try giving them distinctive colors just for fun. No? Oh, is that my only kind of blue now? No, there's the other kind of blue. All right. Okay, so there's the current breakdown. We have these two pieces, which are the same, potentially the same. We have this door. We have that cover. You take the door off, and you have circuits under it. So you can plug in a debugger. You could attach stuff to these pins. Generally do development type stuff on it. Oh, I also missed a comment from AT Makers earlier where they were saying that maybe in Fusion 360 they added folders for this kind of organization. Maybe that is what I'm looking for. Half the battle is knowing what it's called, right? Let's see if there's any help for folders. CAM browser folders, tool library folders. So there are folders in the project level. I don't know, I might be looking in the wrong place. Okay, so we've got the core. We have just the PCB door with a little lip for mounting it. Let's try hollowing this PCB door. I think that might be an interesting exercise. So do we have room? I wanted to try to keep these walls solid because that'll make this whole thing a lot stronger. And just remove, like say, this in the bottom. What is this over here? Is that for the motor? Huh. I don't quite see how that shape just got generated. That's the shape we would expect. It has that little lip, but no other features really. And then stepping forward, we combine that to make oh, is that interfering with the motor? Okay. In that case, let's just make that less deep, so that, because I want this not to just end abruptly here, because that would make a gap. I want it to kind of fold down and to make a nice seam, but I don't want it to go all the way down because then I hit the motor. So before we shell that piece, I want to just trim this a little bit with extrude. And remember, this front face isn't real. That's being removed anyway. So we're just looking at how far this goes down before, before it just stops. And then this piece isn't actually load-bearing. This will be held on by a couple of screws that we haven't placed yet. All right, that did not pick the right faces. Ooh, what's going on there? Huh. Oh. That's something else I need to fix. Let's just use extrude again. That's better. This also needs to come in a little bit. That's fine. That's over here, load cell amp. Whoa. What? What did I do? Okay, that seems better. That's not gonna clear, is it? Maybe it is barely, but I think we can fix that so that there's more room for the RJ45. What's preventing us from moving this down any further? Is that just the motor? No, the motor's not in the way there. Is it just the core of the enclosure being in the way? I think that can just go down further. Let's move the PCB down by a millimeter or two. Okay, so we still haven't made any cutouts there, but if we actually look at the door, I think this will be a little bit better. That whole area is still for the motor. Just a little bit of encroachment between the motor compartment and this, but I think that's fine. Oh, that side needed to go down all the way. Oops. Let's back up. Yeah. Oh, it would be really nice to see more of the inside. I have it on hidden line mode. It just keeps not drawing stuff until I hold still for a while. Well, actually, this is weird. So the view style here, it was actually back on shaded, but I don't think that was right. Because I keep setting this to different values. Like I'll set this to like shaded with hidden lines. Or, okay, wireframe it changed. The other settings I made, it didn't seem to actually have any effect though. Shaded with hidden lines, I get some hidden lines. If I go to shaded, then it's still, okay, that's not what it was doing before. Because before, it was on visual style shaded, but it was still drawing hidden lines, like the UI was just not updated. And this is completely not what I want. Geez, and I just set it to wireframe, and it's still unshaded now. Do you see that? This is not just me, right? This is actually buggy. Maybe the issue was I was using the space mouse at the same time that I changed this, and so that caused it to not take effect. Okay, so this side doesn't need to be there. This is the side that does need to be there. And this is the part where we're avoiding the motor overlap. So I think if I just... There are various ways to do this, but maybe another side cutout is kind of the way to do it. Okay, so this is the same sketch we used to actually carve out the side. And this side over here is where we want the edge to be fully intact. Oh, there's so much stuff going on. Let's hide that. Can we project? Where's the motor? Here's the motor. Ah. for some food. What is this purple thing? It's like projected geometry, but not projected onto any plane that I'm dealing with right now. Project the motor. That's the motor. I'm also still thinking about tolerancing for this. Like the very bottom of this, I want to get close, but maybe the thing to be thinking about is to be, because like over here, I was trying to design an intentional overlap there. Maybe I need to do something similar on this side. Anyway, I think this might be time for a really quick restroom break, because that's something I shouldn't put off too much longer. I'll be right back. I'm probably overthinking all these joints. I just want all the joints to come together nicely. Maybe this is gonna help. Oh no. Apparently I over-constrained this. I can move that. Did I attach this somewhere that I didn't mean to? Huh, I guess I did. I think something else is giving me a distance constraint. I don't know why I can't move this line up and down now. I think this is constrained somehow. This is free to go anywhere. Oh, it attached to, okay, it attached to a point that was projected from the motor. I just want this to be on this line anywhere. And then this, I wanted to set it to be a distance. Something like that. I wonder what happens if we just do that, if that might be simpler. Oh, what were these for again? So these are the two combines. What was this extrude doing? No idea. That was that extrude. Okay. That seems a little nicer. Man, the frame rate bogs down, and then the Space Mouse is like, it's like out of gas. All right, core piece, PCB door. Can we shell this again? So this I can also print with the flat side down, kind of make it a little bucket. Yeah, that's pretty much what I wanted. So then this piece, maybe we just need to make this blue less dark. Maybe that would make everything better. We can always mess with the colors later. very faint red is the circuit board, so we'll need to do more of a cutout for the circuit board now. In fact, this whole thing could just be cut out. So you see you've got that edge. Let's make a sketch for the inside of this compartment, and then we can also use that to clear it out and make some mounting holes. This will be the PCB compartment base sketch. Let's start just by projecting some stuff and extruding. Whoa, not quite like that. Whoops, I didn't actually want to take that all the way up, because then I destroyed my lip there. Let's also make a little more room for this to fit. This is not shelled yet, right? Yeah, this, I might shell this, but it's not quite ready. So I want to open up each of these walls a little bit. Provide a little bit more room for the door to sit. So just like 1/4 millimeter on each side. Great. That little gap is the motor peeking through a little bit. Oh, is the motor going to have any way to get in there? I think we need to maybe clear that out a little bit, because right now, so the deal with this is that the motor is mounting such that the gearbox is flush with this piece of plastic, and then the core, which goes above that, well, once we actually add these features, it'll provide a place for those screws to mount to the motor. Let's name the sketch. PCB mount flat side, maybe. project the cylinder so that I can eradicate parts of it. So I could get it approximately right, but I think I can actually extrude this to the center. I might have to make a reference point for this. Or maybe an axis. This axis really needs a name. Where even are you? Motor axis. I can't extrude that to the axis. Okay, maybe not an axis, maybe something else. Can I make another construction thingy? I can just do a point at the center of one of these circles at the edges of the motor. Motor middle. That seems better. Alfie was asking if there's music on the stream. There shouldn't have been. I don't have to worry about the copyright bot if there is. I wasn't hearing anything here. I don't know. I don't really have a lot of patience for folks who are like, my friends prefer mechanical milling to 3D printing. Since, I mean, so much of it is... I mean, there's a lot of different ways to approach this. You can use 3D printing as a prototyping technique for things you plan to manufacture using other techniques. And then your job is mostly to keep in mind the final limitations of those techniques and to use 3D printing to try to approximate what you're going to make. But then there's also the approach of just designing stuff to 3D print, which is not really super scalable at this point, but it's a lot of fun. And I recommend it. And I think designing things for 3D printing is a lot more fun than complaining about how 3D printing isn't real. So the motor slot's in there. then it just kind of hangs out until this bolts into the next piece. This is really just a place, like the motor could bolt straight onto the other piece, and then this could just act as kind of a snug cover for it, if you can think of it that way. I think I lost my clearances before. I might have to extrude these out again. Yeah, now you can actually see a gap, which is kind of what I'm going for. I don't want every single thing on the motor to be a super snug fit, or it'll just be a pain, and it'll be super over-constrained everywhere. That's also not quite what I wanted. Man, I can't quite select that thing that I want to select. It's when you select something and then it needs to compute for a while. What did I just do? I think it tried to do something really complicated that wasn't what I wanted. That's what I wanted, I think. Can I not extrude that? Maybe I just had to select it before pressing the extrude button. This. Oh, gotcha. Yeah, sorry, I misunderstood your criticism. Yeah, it is very different from the kind of traditional approaches using like a mill and a lathe, but which I really appreciate those approaches too. I don't really do much of it myself, but I mean, I do a little bit of computer-aided machining with my other mill, but you know, I've never used a lathe. I like watching other people use lathes on YouTube, but never had access myself. I think that's fine. I'm just thinking about what to do next. Motor's got a good place to hang out. There's a lot more to do on this side. So prior to shelling this, honestly, I also don't know how much of this needs to be shelled. Some of it does. think maybe before shelling this part, I need to think about mounting screws. I think I also just need to get a bite to eat. But yeah, I think I'll probably wrap up the stream in a bit, get myself a bite to eat, then do probably some more of this stuff off camera. I don't know if you find this particularly interesting. I mean, let me know if you want to see more of this CAD. I feel like for a lot of these projects, it's nice to have a bit of a sample of it, but you don't necessarily need to see like every tiny little design decision that I'm agonizing over. I don't know, there's a lot of stuff I could hollow out. I mean, I think I want a lot of this bottom plate to still be there for mounting the electronics and for structural strength. But like, for example, up here, a lot of this can be hollow. I think I need to think about this a bit more. Oh, I'm sorry if I came across as being good at Fusion 360. I feel like I'm still learning this program and banging my head up against it, but I've also heard, though, that sometimes watching someone else bang their head up against something is a decent way to learn, too. Maybe involves a little less frustration. So yeah, I think that's probably a good wrap-up point for now. We don't have to make every stream 5 hours long, but we'll do some more of this soon. Might stream again later today, although I have a thing I'm going to tonight, so I'm probably not going to have like an evening stream, but might do some more of this off camera and then do another stream tomorrow. And also, as a reminder, if you want to catch up on Tuco in between streams, no guarantees that the camera will be pointed at anything interesting, because he's often off screen, but if you go to twitch.tv/TucoFlyer, you can get basically the same view that we've been having in the corner of the screen, but all the time. And eventually this will actually have the robot we've been building attached to it, so you'll be able to aim the camera interactively using the chat. A chat-directed cat camera, or possibly cat-directed. So. Alright, well I think that's pretty much it. A little bit of Tuco on the way out for everyone. He's such a sweet little cat. Oh yeah, maybe the UX team at Autodesk needs to tune in. I'd be curious about that. I don't know how much this is just like, I'm not their target demographic, and so I'm not like using it how they expect people to use it, or how much of this is just stuff that they could actually improve. Yeah, that would be interesting. Alright, I'm gonna make some soup and then do some more CAD. I'll catch all of you on the next stream. Happy hacking.